Hello everyone, this is Connor with the Aerospace Engineering Fellows. Thanks for tuning in. Today I'm going to be going over a quick high-level explanation of shock waves and expansion fans, and I'm not going to use a lick of math when I do it. All right, it's just going to be pictures. So the big key here, here's the question, and we'll ask this also for fans, but what are shocks and how are they made? And the answer is when you take a gender ambiguous shock fan or a shock wave and it meets another one and it loves it very much, you end up with a little baby shock wave. And it says goo goo gaga. Just like that. And that's pretty much the whole video. Right? They love each other very much, they make a new one. That's not entirely right, but it's close. Here's a definition that Dr. Evans likes to use. Shocks are a violent and abrupt change in flow properties, right? Pressure, not total pressure, pressure, temperature, velocity, right? Those are our, density. Those are our big four, right? Flow properties, right? And this is due to a flow's inability to propagate a disturbance, right? And so what I mean by this is I'll use an analogy to describe this. Imagine you're driving behind a line of cars with a gentle dip in the road, or there's some uphill, right? 36 headed east is a really good example of this. And maybe up ahead you start to see there's some brake lights, and the brake lights, they start here, and then the next car starts braking, and then this car starts braking, and then to brake, right? You can kind of see the transition, the information kind of comes down through these cars. It's very steady and it's very easy, and you're able to account for that, and you're not taken by surprise, right? Now imagine that there's this big U-Haul in front of you, and you have no idea what else is going on, and you're not providing adequate braking distance because you're not a very good driver, right? So if this car starts braking, you're kind of taken by surprise. There's nothing ahead of this to warn you that there's this disturbance, these brakes coming at you, or that you're approaching, and there's nothing really you can do about it until it's right in front of you. It's quite a shock, you might say, to see these brake lights come up. Right now, a good driver, which you guys all are, I'm sorry for accusing you, keeps a nice long braking distance. And so this kind of thing isn't going to affect them. There's not going to be any pileups with you guys. But that's basically the gist of it. That's how I like to think about these shock waves and how they're formed, right? So if you have a subsonic, this is a thin airfoil in a subsonic flow. All these molecules, this molecule right here is going to say like, hey, watch out. Thing in flow. He says, pass it on. Game of telephone. He says, pass it on. This guy says, okay. And he passes it down the line. None of these molecules are taken by surprise. Down in the supersonic regime, though, you might see something like, hey, watch out. And this guy's like, what'd you say? Oh, shit. There's a shock wave, right? Basically what's happening is that this body, I almost called it true anomaly, this thin airfoil is moving so fast that basically these guys can't tell the guy over here like, hey, watch out, move out of the way. This guy's like, can't do anything. And it's kind of like what's going on up here, right? If there's, a wreck up ahead, there's really no way for me, the driver behind this car, to get that information, right? And this, you can even imagine that this shock wave is the analogy breaks down a little bit here because I'm not getting this information because it's obscured, whereas these guys aren't getting this information because they can't tell the molecule behind them fast enough, hey, there's something up ahead, right? I've also drawn an expansion fan here, and this is I don't know if the analogy works quite as well, and I think these are a little easier to understand, even without a huge analogy, but I like to think of it as, you have a flow, it's moving very quickly, and then suddenly there's just a lot of extra room for it to branch out into it. Like it's got room to spread out. I'll draw this on a new one. All right, it's got all this room to spread out. It says, "Oh, that's very nice. Oh, I have lots of extra room now. It's very smooth. Maybe a few lanes open up or something like that. You have more room. You're able to spread out, and it's not violent. It's not a shock, and we're able to use general isentropic assumptions because there's nothing crazy happening here, right?" So that's my quick and dirty explanation of shocks and fans. If you have any questions, please let me know. So leave a comment, and don't forget your shock waves on Valentine's Day. They need love too. All right. Thanks for tuning in, guys.